video. Today we're gonna make a revision on Unit 1 in our booklet, page 45 and 46. So exercise number 1, it says complete. We have the number 2.39 and we wanted to approximate it to the nearest tenth, or it can be written as 0.1, or it's written as in letters as tenth. So we circled the digit tenth and underline the following digit, which is 9. The number 9 is a rich number, so it will increase the number 3 by 1. So we added 1 to the number 3, and this 9 will be cancelled and turn it into 0. And the 3 increased by 1, it will become 4. Then we have the number 2. And it can be written as 2.4. We can cancel the 0 after a decimal point. Question number B. We have 43.07 and we want to approximate it to the nearest 10, or it can be written as this, to the nearest 10. So the number in the 10 digit is the number 4, and underline the following digit, which is 3. All the following digits will be turned into zeros, and we're gonna see the underlined digit, the 3. It is a poor number, it will not gonna increase 4, so 4 will stay as it is. So this number can be written as 40 because we delete the decimal point and the following zeros. Question number C, we have 6.053 or 6 and 53 thousandths, and we want to approximate it to the nearest tenth or to the nearest decimal, one decimal place. The 10th digit is the 0 and the following digit is 5. All the following digits turn it into zeros, and this 5 is a rich number. It will increase the 0 by 1, so this 0 will become 1, and we have the number 6, so our answer is 6.1. Question number D, we have the number 9,456 and it is approximated to be 10,000 to the nearest. So what should we approximate this number to the nearest what to be? 10,000. If I approximate it to the nearest thousand, which is the digit 9, the 4 will not increase the 9 to be 10 because the 4 is a poor number. So if I'm having a digit here in the 10,000th, which is 0, and we approximate to the nearest 10,000, the following digit now is 9. It will increase the number 0 by 1, so it becomes 1, and all the following digits becomes zeros, so we approximate this number to the nearest 10,000. Or we can write it in letters, in digits, as 10,000. Question number E. We want to divide 865 divided by 100. So to divide a number by 100, as you know, we just move a decimal point to decimal places because we have 2 zeros. So we're gonna put a point here, so its answer will be 8.65. Then we will need to approximate this number to the nearest tenth. As we said before, it can be written as 0.1. So the 10th digit here is the number 6. And the following digit is 5. 5 is a rich number, it will be turned into 0. And because it is rich number, it will increase 6 by 1. So 6 becomes 7. And we have 0 and 8. So our answer will be 8.7, and we can cancel the 0 after the decimal point. Let's move to question number 2. Put right or wrong. So we're gonna see the statement, and whether it is right, we're gonna put right, or it is wrong, we're gonna put wrong. 45.256 approximately equal 45 when approximated to the nearest tenth. Where is the 10th digit? It is the 2, and the following digit is 5. To approximate this to the nearest tenth, all the following digits turn it into zeros, and because 5 is a rich number, it will increase this 2 by 1, so 2 will become 3, and we have 45. So the correct answer must be 45 and 3/10, but he says that the answer is 45, so this is a wrong statement. Question number B. 5,968 is approximately equal 6,000 when approximated to the nearest thousand. Here is the unit, tens, 100,000. Here is the digit we want to approximate, and the following digit is 9. All the following digits turn it into zeros, and 9 is a rich number. It will increase this 5 by 1, so 5 will become 6. As he said, the answer will be 6,000, so this is a right statement. Question number C. 187 and 6/10 is approximately equal to 180 to the nearest 100. The 100 digit here is 1, and the following digit is 8. If we approximate this number to the nearest 100, we're gonna turn all the following digits into zeros, and 8 is a rich number. It will increase this one by another 1, so it will be 2. So the answer is 200, not 280, so this is a wrong statement. The next question, we have 753 centimeters. It is approximately equal 8 meters. So how can we approximate a number from centimeter into meters? First, we have to change this number into meters. So 753 centimeter equal how many meters? Let's remember how to convert from meter to centimeter, as we have taken before, the kilometer, then meter, then decimeter, then centimeter, then millimeter. From kilometer to meter we multiply by 1000, from meter to decimeter by 10, from decimeter to centimeter by 10, and from centimeter to millimeter multiplied by 10. If you are going back, we divide here by 10, and here also by 10, and here also divided by 10, and the last one divided by 1000. So now we have the number beside the centimeter, so we are standing at the centimeter, and we want to go back to meter, so we have to move from centimeter all the way back to meter, so we're gonna divide by 100. So let's take this number and divide it by 100. 753 divided by 100 equal, when dividing any number by 10 or 100 or 1000, we just put a point, and here we will put a point after 2 digits because we have 2 zeros. So this is 1, 2, we're gonna put a point here, so the answer is 7.53 meters. Now 753 centimeters equal 7.53 meters. Then we're gonna make the approximation. So this value in centimeters equal 7.53 meters. So this value is equal 7.53 meters, and to approximate it to the nearest meter means to approximate to the nearest unit. And the unit is always before, yes, the point. So the unit digit is 7, we circle the digit 7 and underline the following digit, which is 5. So the number 5 is a rich number. It's gonna be turned into zeros and have a point. Because 5 is a rich number, it will increase this 7 by 1, so this 7 becomes 8. So this is approximately equal 8 meter, and it is the same answer, so this statement is correct. Question number A, we have 82.05, and it is approximately equal 82.5 to the nearest tenth. The 10th digit here is 0, and the following digit is 5. Following digit, always turn it to 0. This is a rich number, it's gonna increase the 0 by 1, so this 0 becomes 1. And we have 2 and 8. this is not the answer, so this statement is wrong. Let's move to another question. Question number 3, choose. We want to choose the correct answer in the following. We have 100 days approximately equal how many weeks? Let's make it as we studied before, to change from week into days. Each week contains 7 days, and if you're gonna turn back, you will divide by 7. So let's say 100 days. So let's see 100 days equal how many weeks? To change from day to week, we're gonna divide by 7. So I'm gonna take the 100 day and divide it by 7. To make this division, I'm gonna do a little help with table 7. Here we have up and down, 1, 2, 3, 4, 5. We're gonna make table 7. 7 by 1 equals 7, 7 by 2 equals 14, by 3 21, by 4 28, by 5 35. And because we have one digit outside, we're gonna take one digit. 1 divided 7 is too small to divide 1 among 7, so we're gonna take 2 digits, which is 10. 10 divided 7, the nearest result to 10 is 7. I'm gonna choose this one. I'm gonna put 7 down and 1 up. Then we subtract. 10 minus 7 equal 3, and bring down the following number, which is 0. Now we have 30. 30, let's search down for 30. There is no 30. So the nearest result to 30 is 28. I'm gonna choose 28. I will put 28 down. And it has 4 up. I'm gonna put 4 up. And then subtract. 30 minus 28, we have 2. So the result is we have 14 after division, so this is 14 week, and the remainder is 2 days. So 100 day equal 14 week and 2 days. So the answer is 14 week and the remainder is 2 days. We can say that the 2 days is approximately equal a week. So the answer will be 14. We're gonna choose this is approximately equal 14. Next question. $371 and 456 thousandths approximately equal what to the nearest 100? Here is the unit, 10 100. I'm gonna circle the 100 digit and underline the following digit. Then we're gonna make the approximation. All the following digits will turn it into zeros. And because of 7 is a strong number, it will increase the 3 by 1, so this 3 becomes 4, and we can cancel the decimal point and the following zeros, so the answer is 400. Question number C. The number which if approximated to the nearest tenth, and the result will be 0.8. So which of these numbers, when approximated to the nearest tenth, the answer will be 0.8. Let's see this number. Here is the 10th digit, and the following digit is 1. 1 is a poor number, it cannot increase 8, so 8 will still as it is, and this one will turn it into zeros, so I'm gonna totally choose 0.81. The other two answers, when approximated to the nearest tenth, this 8 is the 10th digit and the following number is strong, it's gonna make this 8 9, and we want the result to be 0.8. And the last one is 1, absolutely not gonna approximate it to be equal 0.8. The last one, we have 38,000. It is the approximation of this number to the nearest what. So we approximate this number to what? To be 38,000. As we notice that the digit 7 becomes here 8. So we just increase this 7 by 1 to be 8, and the following digits are turned into zeros, so we approximate the number to this digit, which is the 1000th digit. So I'm gonna choose the 1000. Last question in choose. We have 59.95, and we want to approximate it to the nearest 10th. The 10th digit here is the 9, and the following digit is 5. The following digit turn it into 0. This 5 is a strong number. It will increase this 9 by 1. After 9 we have 10, 0 and carry up 1. We have a decimal point. 1 plus 9 is 10, 0 and carry up 1. 1 plus 5 equal 6. So we can cancel point and two zeros after the decimal point, and the answer will be 60, and we have to choose 60. Let's move to another question, question number 4. Find the result. We're gonna make the operation, even if it is addition or subtraction, then we will approximate the result according to the bracket. So first, let's make question number A. I will make this addition by putting a point, under it another point, and I take a line, under it another point. Then I'm gonna write the numbers. We have 14 and 102, added to 8 and 135. If you have an empty digits, you're gonna fill it with 0. Then we're gonna add 2 plus 5 equals 7, 0 plus 3 equals 3, 1 and 1 equal 2, 4 and 8 is 12, 2 and carry up 1, 1 and 1 is 2. So the result is 22.237. Then we approximate this result to the nearest 10th. The 10th digit here is the number 2, the first decimal place, and the following digit is 3. All the following digits turn into zeros. This 3 is a poor number, so 2 still as it is. Then we have 22. Next question. We're gonna subtract. I'm gonna do it outside like the previous one to get the answer. Then we're gonna approximate. I'm gonna put a point, under it another point, then take a line and another point. We have 534. After the point we have 46 minus 79 and 864. If you have an empty digit, you have to fill it with zeros. Then we are making a subtraction. Let's subtract. 0 minus 4 cannot be. We're gonna borrow 1. This will be 5 and this will be 10. 10 minus 4 equals 6. 5 minus 6 can't be. We're gonna borrow. This will be 3. This will be 15. 15 minus 6 equals 9. 3 minus 8 can't be. We're gonna borrow. This will be 3. This will be 13. 13 minus 8 equals 5. 3 minus 9 can't be. We're gonna borrow. This will be 2. This will be 13. 13 minus 9 equals 4. 2 minus 7 can't be. We're gonna borrow. This will be 4. This will be 12. 12 minus 7 equals 5. 4 minus 0 equals 4. So our answer is 454 and 596 thousandths. Then we're gonna approximate to the nearest one decimal place, or the first decimal place, which is the first decimal number, which is 5. And the following digit is 9. All the following digits turn it into zeros. This 9 gonna increase the 5 by 1, so this 5 will be 6, and we have a decimal point, then 4, 5, 4. Next question. We want to subtract 3.5 minus 1 3/4. To subtract this, First, I'm gonna change 1 3/4 into decimal. As you remember, if you have a fraction, mixed number like this, and you want to turn it into a decimal number, you will search for its a friend. The friend of 4 is 25, and then multiply upwards the same number, 25. We have 1. 3 by 25 is 75, and 4 and 25 give us 100, so this is equal 1.75. Then I'm gonna make the subtraction by putting a point under it, another point, take a line, another point. The first number is 3.5. We subtract from 1.75. We have an empty digit, we fill it with 0. Then subtract 0 minus 5 can't be. We will borrow, this will be 4, this will be 10. 10 minus 5 equals 5. 4 minus 7 can't be, this will be 2, this will be 14. After 7, 8, 9, 10, 11, 12, 13, 14. So this is another 7. And 2 minus 1 equals 1. So the answer is 1.75. Then we approximate to the nearest tenth. The 10th digit, or the first decimal place, is 7, and underline this 5 turned into 0. 5 is a strong number, it increases 7 by 1, it becomes 8, and we have point and 1. We can cancel this 0, so the answer is 1.8. Question number 2. We're gonna make addition. So let's add. We put a point under another point, take a line, and another point. The first number is 134 and 2/10, and then 28 and 4300. We add the empty digit, fill it with 0. Here we have 0 and another 0. So 0 plus 3 equals 3. 2 plus 4 equals 6. 4 plus 8 is 12. 2 and carry up 1. 4 plus 2 is 6 and 1. So the answer will be 162.63 hundredths. Then we're gonna approximate it to the nearest 100, and here is the unit, 10th hundred. It's a 100 digit. We circle it and underline the following. All the following digits turn it into zeros. We can cancel the decimal point and the following zeros. The number 6 gonna increase 1 by another 1, so it will be 2, and we have 2 zeros, so our answer will be 200. Question number 5. Complete using a suitable digits. We have to complete the following question using a suitable digit to get this answer. So, what should I put here to this number? Because when it's approximated to the nearest tenth, it becomes 28.1. Whereas the 10th digit here, it is a 0. We want to increase this 0 to become 1. So here we have to put a strong number. You can put a number like 5, like 6, like 7, like 8, like 9. Any strong number. I'm gonna choose any one of them, which is 6, and this will get me the answer 28.1. The next question, we have 60 point what and 5. When it is approximated, it will be 60, and we approximate to the nearest unit. The unit digit always before the point. So I want to preserve this 0 to become as it is, a 0. So I need here the following digit to be a weak number. So I can put 0 or 1 or 2 or 3 or 4. You can choose any weak number. I will choose the number 2. It will give me the same answer. The 2 is a weak number. It will not gonna increase 0, so the approximation will be correct, 60. Okay. The last question, write the smallest decimal number, which consists of the numbers 6, 5, 1, and 7. So we're gonna pick these numbers and form from these numbers the smallest decimal number. Then we will approximate this number to the nearest 10th. So I will start with the smallest decimal number. The smallest number in these numbers is 1. Then I can put a decimal point. Then I have taken 1. We have 5, 6, 7. I'm gonna put them 5, 6, 7. So this is the smallest decimal number formed from 1, 5, 6, and 7. Then we want to approximate it to the nearest 10th. The 10th digit is the first decimal place, and underline the following digit. All the following digits turned into zeros. This 6 is a strong number. It will increase 5 by 1. So this 5 becomes 6, and we have point and the number 1. So the answer is approximately equal 1.6. Our video is finished. I want you to evaluate yourself by solving the quiz in booklet page 47. And for any comments or any questions, I will be with you on Telegram to answer your questions. Thank you and see you in another video.